So in this today's lesson, we're going to be talking about thermal conductor. When we're talking about thermal conductor, we're talking about heat transfer. Heat transfer. Ne? So we have three types of ways in which we transfer heat. The first one, we have conductor. We transfer heat by a conductor, and also we transfer heat by radiation. Heat is transferred by radiation, and also heat is transferred by convection. So there's the three ways in which heat is transferred. So let's say, for example, we have a heat this side, which is 35 degrees Celsius. This side is hot. And then we have another portion, which is a temperature is 10 degrees Celsius, which we can say is cold. It is cold. So how can we transfer this heat? How can heat be transferred? It can be transferred through a thermal conductor. This is our thermal conductor. So that thermal conductor, heat will move from hot to cold, which means heat will move from this side up until this portion. This is how heat will move. Will move from hot to cold. But if we had temperature that is equal on both plates, like 30 this side and 30 this side, there will be no heat transfer because the temperatures are equal. Understand? So let's talk about this thermal conductor, this guy here. It is the thermal conductor. So with our thermal conductor there, thermal conductor is denoted by letter K. This is the thermal conductor. So heat will travel a certain distance from here up until here. It is a certain distance that a heat will travel with. We can call that distance D. Ne? So meaning that from here up until here, it is the distance that will be traveled by the what? By the heat. That distance must be measured in what? In meters. Sometimes that distance, it is called the thickness. It is called what? The thickness of the conductor. It is the thickness of the conductor. How thick it is our conductor. Understand? So remember, when the heat is traveling, it is traveling at a certain area. Understand? There is an area that distance is traveling with. Understand? So whenever that the heat is traveling, it is traveling through a certain area. A certain area. Do you understand? So that shape of a conductor, it can be circular shape. It can be circular shape like this. Understand? So when it becomes circular shape, which means the area of that thing will be equal to pi r squared. So remember the radius is half of this circle. So we can be given the diameter or the radius of that conductor. Sometimes our conductor can be rectangular or square shape. So which means whenever it becomes like this, what will happen to our area? Our area will be length times breadth. Understand? So which means heat will travel through a what? Through an area. Will travel through an area A by a distance D. A distance D. Understand? So the area will have the SI unit of meter square, and the distance will only have the SI unit of meters. Do you understand? So we can call this one our area. Then from there to there is our distance. So how can we calculate K? K, remember, is our what? Is our thermal conductor. K is our thermal conductor. So how can I calculate my thermal conductor? You must know that the heat the heat which is denoted by Q, measured in joules, it is equal to the mass multiplied by the specific heat capacity, then multiplied by the change in temperature. So let's write it again. We must know that the heat which is measured in joules is equal to the mass multiplied by the specific heat capacity, then multiplied by the change in temperature. So we are going to use implicit differentiation here, d over dt. Even this side I'm going to multiply by d over dt. So what is my purpose is to find the rate there. So if we can check very well, my mass and my specific heat capacity, when we are transferring the heat, the mass does not change, and also the specific heat capacity of that material does not change. Only the temperature is changing. Understand? Which means my mass and my specific heat capacity, they are constant. So which means from here I will get my dq over dt, which is equal to the mass remains constant and the specific heat capacity remains constant, then multiply by what? By the change in temperature over dt. Understand? That is what is happening there. So again, I'm looking for K. I must just know that what? dq over dt, which is the same as the change in what? The change in heat over the change in time, is the same as the gradient, is the same as we are deriving, is equal to what? Is equal to K, which is my what? My thermal conductivity, multiplied by A. What is A? A is our area here, is our area of the conductor. This is our A here. And also multiply by what? The change in temperature. Understand? The change in temperature, all divided by what? All divided by what? The thickness or the distance traveled by the heat. Understand? So all divided by what? By D. So you must know that formula by heart. Understand? So which means we now know that what? That dq over dt is equal to the mass multiplied by the specific capacity multiplied by the change, the change in temperature over dt, which is also equal to the K, which is what? The thermal conductor, A, which is the area, the change in temperature, all divided by distance, D, or the thickness. So let's talk about the SI unit of K. Before that, the SI unit of K will depend on our variables. So there I have dq over dt. So which means the SI unit will be what? Will be joules over seconds. Joules is the SI unit of the heat, second it is the SI unit of time. So joules over second, it is the same as work over time. Understand? So work over time, we know it is equal to power. Understand? So what is the SI unit of power? The SI unit of power is watts. Understand? So meaning basically, for every 1 joule per second, we have what? We have 1 watts, which means this SI unit are equal. Understand? Which means I can just simply say what? The SI unit of dq over dt, it is the same as watts. So how can I find the SI unit of K? So now let's talk about the SI unit of the change in temperature. So the change in temperature is equal to temperature final minus temperature initial. So the temperature final is measured in degrees Celsius minus the temperature initial, it is measured in degrees Celsius. But the change, when you are subtracting the 2 degrees Celsius, when you are subtracting them, we get Kelvin instead of degrees Celsius. But even if you say degrees Celsius, it's still fine. But for future purposes, we must know Kelvin is the difference between two temperatures. Understand? Meaning our change in temperature, this one, is measured in Kelvin. Understand? So now, let's try and find the SI unit of K. We know that dQ over dt, it is equal to K multiplied by the area multiplied by the change in temperature, all divided by d, which is the thickness. So let's substitute our SI unit. The first SI unit on the left hand side is watts, which is the SI unit for power, or for the dq over dt. Then we have our K there. The SI unit for area is meter square. The SI unit for temperature is Kelvin. The SI unit for distance is meters. If you can check the meters, they cancel one of them there. Then from there, we remain with what? With watts, which is equal to what? Which is equal to our K multiplied by what? Multiplied by M, which is the distance, multiplied by K, which is the one for temperature. Therefore, when I divide both sides, I get that the SI unit for thermal conductor is watts per watt per meter per Kelvin. Or, remember what is the same as what? Is the same as joule per second, which means it's joule per second all divided by what? Meter per Kelvin, or they can say per degree Celsius, or they can say like this, mass per Kelvin. That is the SI unit for thermal conductor. And again, we have what we call R values. R value, it is equal to what? It is equal to the thickness of the what? Of the conductor divided by the what? By the thermal conductor K. We call them R values. It is the R value. So this is the introduction of this chapter of thermal conductor heat transfer. So we're going to do questions after.